Good morning all. Today I am going to discuss about the topic enzymes. So what are enzymes? Enzymes are basically biocatalysts. So enzymes are biocatalysts synthesized by living cells that accelerate a biochemical reaction. So inside our living organism, the enzymes are catalyzes a chemical reaction. So coming to definition of enzymes are the catalyst. They increases the velocity or rate of a chemical reaction without itself undergoing any change in the overall process. And the enzymes are mainly protein in nature, and it is colloidal and thermolabile, and it is specific in action. So the enzymes are biocatalysts which speed up or accelerate a chemical or a biochemical reaction without undergoing any change in the overall process. And the enzymes are mainly protein in nature, and they are thermolabile. That means the temperature affects the enzyme activity. Next is the properties of enzymes. So we have already told that enzymes are the biological catalyst. They lowers the activation energy. The activation energy means energy required to start a reaction or a chemical reaction. So the enzymes are lowers the activation energy required for a chemical reaction to proceed. And the third property, enzymes speed up the rate of the reaction. And the enzymes are protein in nature. The enzymes remain unchanged after a reaction and therefore they can work again. Then the enzymes are specific to a substrate of a reaction. That means lock and key system. So each reaction having a specific enzyme. So the enzymes are specific in nature. For example, the enzyme sucrase catalyzes the hydrolysis of only sucrose and no other substances. So the enzyme sucrase only activate or catalyzes the hydrolysis process of sucrose. So the enzymes are specific in nature. Next property, enzymes are reversible and can speed up a particular reaction either in forward or backward direction. So enzymes are reversible in nature and it can speed up a particular reaction. For example, the enzyme catalyzes a reaction going both ways. That means synthesis or lysis. That means for breakdown and for the building up, the enzymes are used. The next property, enzymes are colloids and are soluble in water and dilute alcohol, but they are precipitated by concentrated alcohols. Next property, enzymes are denatured by the change in temperature and pH. So an optimum temperature is required for the effective functioning. The next property, only a small quantity of enzyme is needed for the reaction. So these are the properties of enzymes. The first one, catalytic property. Second property, specificity. Third one, heat sensitivity. Fourth one, pH sensitivity. And the fifth one, reversibility. So these are the properties, the main properties of an enzyme. Next is the structure of enzyme. So mainly the enzyme having two sites. First one is active site and the second one is a prosthetic site. So the active site of an enzyme is the region that binds the substrate. Substrate means reaction intermediates and cofactors. The second site is prosthetic groups. The prosthetic groups contains S residues that helps to hold the substrates. So mainly the enzyme having two sites, one active site and the remaining prosthetic group. The active site means region that bind the substrate or the cofactor, and the prosthetic group that contain S residues that will hold the substrate. The active site has a specific shape due to tertiary structure of protein, and a change in the shape of protein affect the shape of active site and function of the enzyme. So this is the structure of enzyme. The enzyme having active site. The active site means where the substrate will bind. So the active site The substrate will bind to the active site of enzyme and it will form an enzyme substrate complex. After that, the enzyme substrate complex is converted into product by the release of free enzyme. So next is the nomenclature of enzymes. So for the nomenclature or the naming of enzymes, we have to add ASE to the suffix portion of the particular enzyme. For example, lipase act on lipids. So here lipase is the enzyme. So we are adding ASE to the suffix portion. The next example, nuclease act on nucleic acids and lactase on lactose. So these are all known as trivial names of enzymes. So these types of naming are trivial names, but it fails to give the complete information of an enzyme reaction. Next is the classification of enzyme. So International Union of Biochemistry in 1964, the enzymes are classified into 6 classes. So based on the nature of the reaction. So within each class there are subclasses. So the different types of enzymes are: first one oxidoreductases, second one transferases, third one hydrolases, fourth one isomerases, fifth one lyases, and the last class, that is ligases. So these are the different classes of enzymes. So this is the different classes of enzymes and their reaction catalyzed and the examples of that particular class. So the first class is oxidoreductases, the reaction catalyzed oxidation reduction reaction, and the example is alcohol dehydrogenase. Second one is transferases, the transferases catalyzes the transfer of functional groups. The example is hexokinase enzyme. The third class, hydrolases. The hydrolases enzyme catalyzes hydrolysis reaction, and the example is lipase and pepsin. The fourth one, isomerases. Isomerases catalyzes isomerization reaction. That means or interconversion of isomers. The examples are triose phosphate isomerase. The fifth one is lyases. Lyases catalyzes the reaction of cleavage of bond. The example is aldolases. The last class, that is ligases. Ligases catalyzes the reaction of ATP cleavage or condensation reaction. The example is glutamine synthetase. Next is the factors affecting enzyme activity. So there are mainly 8 factors which affect the enzyme activity. So the first one is concentration of enzyme, second one is concentration of substrate, third one is effect of temperature, fourth one is effect of pH, fifth one is effect of product concentration, and effect of activators, effect of time, and the last one, that is effect of light and radiation. So these are all the factors which affect the enzyme activity. So the first factor, that is concentration of enzyme. So as the concentration of enzyme is increased, the velocity of the reaction or speed of the reaction also increases. So it is directly proportional to the activity of enzyme. The rate of reaction is directly proportional to the concentration of enzyme when the pH, temperature, substrate concentration are constant. So when we plot a graph between enzyme concentration and enzyme velocity, we will get a straight line graph. Next is the concentration of substrate. So as the increase in the substrate concentration, which will gradually increases the velocity of enzyme reaction within the limited range of substrate level. That means at a particular level, the velocity of enzyme also increases as the concentration of substrate increases. But after that, at a maximum point, it will stop and it will took a straight line. So a rectangular hyperbola is obtained when the velocity is plotted against the substrate concentration. So we can see that 3 points are there, A, B, C. So A is the linear, B is the curved, then C is almost unchanged. So at the point C, the velocity of the enzyme remains unchanged. Next is the effect of temperature. So velocity of an enzyme reaction increases with the increase in temperature. temperature up to a maximum and then declines. So we will get a bell-shaped curve for the graph. Next is the effect of pH. So increase in the hydrogen ion concentration considerably influences the enzyme activity, and a bell-shaped curve is normally obtained. So most of the enzymes of higher organism show optimum activity around neutral pH, that is 6 to 8. Next is effect product concentration. So the accumulation of reaction products generally decreases the enzyme velocity. So accumulation of product increases, then the enzyme velocity also decreases. Next is effect of activators. So some of the enzymes require certain inorganic metallic cations like magnesium ions, manganese, zinc, calcium, copper, sodium, potassium, etc. for their optimum activity. So activators are the compounds which will enhance the activity of an enzyme. So some of the enzymes having these metallic cations, so that their optimum activity, so that they will show their optimum activity. Next is effect of time. Under ideal and optimum conditions like pH, temperature, the time required for an enzyme reaction is less. The last factor is effect of light and radiation. The exposure of enzyme to ultraviolet ray, beta ray, gamma and X-rays inactivate certain enzymes due to the formation of peroxides. For example, UV rays inhibit salivary amylase activity. So these are all the factors which affect the enzyme velocity. Next is the enzyme inhibitors. So an inhibitor is a compound which will stop or decreases the activity of an enzyme, that is inhibitor. So enzyme inhibitor is defined as a substance which binds with the enzyme and brings a decrease in the catalytic activity of that particular enzymes. So the inhibitors can be organic or inorganic in nature. So there are mainly three categories of enzyme inhibitors. The first one is reversible inhibition, second one is irreversible inhibition, and the third one is allosteric inhibition. So the first one is reversible inhibition. So what is reversible inhibition? The inhibitor binds non-covalently with the enzyme, and the enzyme inhibition can be removed if the inhibitor is removed. That is reversible inhibition. So the reversible inhibition are further classified into two types: competitive inhibition and non-competitive inhibition. So in that competitive inhibition, that is the inhibitor closely resembles the real substrate. അതായത് real substrate in the same resemblance അല്ലെങ്കിൽ അതിന്റെ structural similarity ആയിരിക്കും ഈ ഇൻഹിബിറ്ററിന്. So the inhibitor competes with the substrate and binds at the active site of enzyme but does not undergo any catalysis. ഇപ്പം ഇൻഹിബിറ്ററും സബ്സ്ട്രേറ്റുമായിട്ട്, ദ റിയൽ സബ്സ്ട്രേറ്റുമായിട്ട് അവിടെ ഒരു കോമ്പറ്റീഷൻ ആണ് നടക്കുന്നത് ഫോർ ദി ബൈൻഡിങ് ഓഫ് ദ ആക്റ്റീവ് സൈറ്റ് ഓഫ് എൻസൈം ബട്ട് ഡസ് നോട്ട് അണ്ടർഗോ എനി കാറ്റലിറ്റിക് പ്രോപ്പർട്ടി. ദ ഇൻഹിബിഷൻ ക്യാൻ ബി ഓവർകം ബൈ എ ഹൈ സബ്സ്ട്രേറ്റ് കോൺസെൻട്രേഷൻ. അപ്പം സബ്സ്ട്രേറ്റിൻ്റെ കോൺസെൻട്രേഷൻ ഇൻക്രീസ് ചെയ്യുമ്പം അവിടുത്തെ ഇൻഹിബിഷൻ അവിടെ നമുക്ക് ഓവർകം ചെയ്യാം. ഫോർ ദ കോമ്പറ്റേറ്റീവ് ഇൻഹിബിഷൻ ദ Km value increases whereas Vmax remains unchanged. Km means Michaelis Menten constant value that will be increases in competitive inhibition and the maximum velocity remains unchanged. As an example, the enzyme succinate dehydrogenase with succinic acid. So the compounds malonic acid, glutaric acid and oxalic acid having the structural similarity with this enzyme. Okay, with this succinic acid and compete with the substrate for binding at the active site of SDH. That means ഇപ്പം നമ്മുടെ enzyme is succinate dehydrogenase, അതിൽ ബൈൻഡ് ചെയ്യാനുള്ള അല്ലെങ്കിൽ കോമ്പറ്റേറ്റ് ചെയ്യുന്ന inhibitors are the malonic acid, glutaric acid and oxalic acid. The real substrate is succinic acid. So the real substrate എന്ന് പറയുന്നത് succinic acid which അതിൻ്റെ റിസംബ്ലൻസ് വരുന്ന ഇൻഹിബിറ്റേഴ്സ് ആണ് malonic acid and glutaric acid. So that compete with the substrate for binding this enzyme. So these are all the examples of competitive inhibition. So the enzyme is xanthine oxidase, the substrate is hypoxanthine or xanthine. So the inhibitor is allopurinol. So the allopurinol having the structural similarity of xanthine oxidase. So the significance of these inhibitors used in the control of gout to reduce excess production of uric acid from hypoxanthine. So the next one is the enzyme vitamin K epoxide reductase. So the substrate is vitamin K and the inhibitor is dicumarol. So the dicumarol having the structural similarity of vitamin K epoxide reductase. Sorry, vitamin K substrate. So the vitamin K and dicumarol having a competition for the binding of the enzyme vitamin K epoxide reductase, and the significant is the inhibitor is which is act as an anticoagulant. The third one is acetylcholine esterase enzyme. The substrate is acetylcholine and the inhibitor is succinylcholine. So here the succinylcholine having the structural similarity with the substrate acetylcholine, so there will be a competition for the binding of acetylcholine esterase, and the significance is which is used in the surgery for muscle relaxation. And the last one is monoamine oxidase. Here the substrate is catecholamine. The inhibitors are ephedrine and amphetamine, and it is used for elevating catecholamine levels. So these are all the examples of competitive inhibition. The second one is non-competitive inhibition. So here in non-competitive inhibition, the inhibitor binds at a site other than the active site on the enzyme surface, and it will impair the function of enzyme. So the inhibitor has no structural resemblance with the substrate, so there exists a strong affinity for the inhibitor to bind at the second site. Here the inhibitor does not interfere with the enzyme substrate binding. The catalysis is prevented due to the distortion in the enzyme conformation. For example, heavy metal ions, for example, silver, lead, tin, etc., can competitively inhibit the enzyme by binding with cysteine sulfhydryl group. അതായത് the heavy metals enzymes cysteine sulfhydryl groups വന്ന് bind ചെയ്യും, that is the other than the active site. So this is the representation of non-competitive inhibition. Here the enzyme having substrate site and the the enzyme having the active site and the other than active site. The substrate and inhibitor, the substrate will bind to the active site of enzyme and the inhibitor binds to the site other than the active site. It will form an enzyme inhibitor complex. So there will be no reactions are takes place and the shape of the active site will be changed. Next one is irreversible inhibition. So in irreversible inhibition, the inhibitors bind covalently with the enzyme and inactivate the enzymes. So these inhibitors are usually poisonous substances. For example, iodoacetate is the irreversible inhibitor of the enzyme like papain and glyceraldehyde 3-phosphate dehydrogenase. So iodoacetate combines with the sulfhydryl or SH group at the active site of the enzyme and make them inactive. The second example is diisopropyl fluorophosphate, which is irreversibly binds with the enzyme containing serine at the active site. For example, serine proteases and acetylcholine esterases. So these are the examples of irreversible inhibition. Next example is disulfiram. It is a drug used in the treatment of alcoholism which inhibit the enzyme aldehyde dehydrogenase. Next example is penicillin antibiotics. So the penicillin antibiotics act as irreversible inhibitor of serine containing enzyme and block the bacterial cell wall synthesis. Next is suicide inhibition. So the suicide inhibition is a specialized form of irreversible inhibition. And here the original inhibitor is converted to a more potent form by the same enzyme that ought to be inhibited. The so formed inhibitor binds irreversibly with the enzyme. A suicide inhibitor is a relatively inert molecule that is transformed by an enzyme and its active site into a reactive compound that irreversibly inactivate the enzyme. So suicide inhibition എന്ന് പറയുന്നത് the original inhibitorനെ കുറച്ചുകൂടെ active form of the inhibitor ആയിട്ട് മാറ്റുകയാണ് ചെയ്യുന്നത്. Then it will irreversibly inhibit the enzyme. Next is the examples of suicide inhibition. So the first one is allopurinol. So allopurinol is an inhibitor of xanthine oxidase, which gets converted into alloxanthine, a more effective inhibitor of the enzyme. Second example is 5-fluorouracil, which act as a suicide inhibitor of thiamidylate synthase. 5-fluorouracil gets converted to fluorodeoxyuridylate, which is an active form, and it inhibits the enzyme thiamidylate synthase and thus nucleotide synthesis in a blockade. Next is allosteric inhibition. So some of the enzymes possess additional site known as allosteric site beside the active site. Such enzymes are known as allosteric enzymes. So active site other than the active site, the enzyme having some portion that is known as allosteric site. So allosteric inhibition means the inhibitors which bind to the allosteric site of the enzyme, that is allosteric inhibition. So here we will see that the enzyme having the active site other than the active site which is allosteric site. So here in the allosteric site the inhibitor binds to the allosteric site, that is allosteric inhibition. So it will so it will change the shape of the enzyme. That means distorted active site, so the substrate cannot bind to the actual active site of the enzyme. So this is a diagram of allosteric inhibition. So in allosteric inhibition, the inhibitor binds to the allosteric site and alter the conformation of or inactive site of the enzyme, which consequently changes the shape of the active site. Thus the enzyme no longer remains able to bind to its specific substrate. Hence the enzyme is unable to perform its catalytic activity, that is enzyme is now inactive. So these are the examples of allosteric inhibition. So the first one is glucose-6-phosphate act an allosteric inhibitor of the enzyme hexokinase. The second example is palmitate is an allosteric inhibitor for acetyl-CoA carboxylase in fatty acid synthesis. Next is enzyme kinetics. So enzyme kinetics is the study of chemical reactions that are catalyzed by the enzyme. Here the reaction rate is measured and the effect of varying the conditions of the reaction is investigated. So according to this model, the enzyme reversibly bind with the substrate to form an enzyme substrate complex which subsequently yields the product. For example, enzyme plus substrate gives enzyme substrate complex, and after that the enzyme substrate complex is converted into E plus P, that is enzyme plus product. So here S is the substrate, E is the enzyme, ES means enzyme substrate complex, P is the product, and K1, K2, K3 are the rate constant. So the first step, enzyme reacting with substrate to form enzyme substrate complex, it is a reversible reaction. That means enzyme substrate complex can be converted into enzyme and substrate. So for enzyme kinetic study, we have to calculate the Km value. Km means the Michaelis-Menten constant, or also known as Briggs and Halderson constant, is given by the formula Km is equal to K2 plus K3 divided by K1. So the following equation is obtained after the suitable manipulation, that is V is equal to maximum velocity of the substrate divided by Km, that is Michaelis-Menten constant plus concentration of substrate. That is the first equation. So here V is the measured velocity, Vmax is the maximum velocity, S is the substrate concentration, and Km is Michaelis-Menten constant. So here we have to assume that the measured velocity V is equal to half Vmax. So the equation will be substituted as Vmax by 2 or half Vmax is equal to the maximum velocity of substrate divided by Michaelis-Menten constant plus concentration of substrate. Then, so that is the equation number 2. Next, we have to divide both sides by Vmax. Then we will get, so we will get half or 1 by 2 is equal to concentration of substrate divided by Km plus concentration of substrate. So here Km plus, then we have to cross multiply this, then we will get Km plus S is equal to 2S, then Km is equal to 2S plus S. So we will see that Km is equal to 2S minus S, so Km is equal to S. So Km or Michaelis-Menten constant is defined as the substrate concentration which is expressed in moles per liter, that is to produce half maximum velocity in an enzyme catalyzed reaction. So it indicates that half of the enzyme molecule, that means 50% of the enzyme molecule are bound with the substrate molecules when the substrate concentration equals the Km value. So when we will plot a graph between concentration of substrate and half Vmax, we will get in a hyperbola. So this is the enzyme kinetics.